Let's advance to the last part. Angel has been hired by the city to plant ghost peppers in the park. Again, the number of seeds he plants will not be the same as the number of peppers that actually grow. Answer the following questions to help Angel plan for his park job. You get to decide how many of the planted ghost pepper seeds will sprout. Create a table of X and Y values that represent a proportional relationship for your ghost peppers. So there's a new plant, and you get to determine what the constant of proportionality is. In other words, the relationship between how many you plant and how many actually grow. Let's make a table over here. It's very important we don't just leave this as X and Y, because the problem's asking us specifically about amount planted versus amount that actually grow. So X is going to be our planted amount, just like in the last problem. And Y is going to be how many grow. This is for our ghost peppers. And we saw in our last problem, our K value is 1/5. So if you plant 5, only one of those would have actually grown. I'm going to pick some other random number. I'm just going to go 1/8. And I'm going to pick some random X values, but that are going to be easy for me. So if I'm saying K is 1/8, that means one of them grows for every 8 that I plant. And matter of fact, there's some of our first values you can use. We can say we plant 8 and 1 grows. Again, I just chose this 1/8, and you can choose anything. You do 1/3, 1/6, 1/5, whatever. Or maybe whatever you think makes sense. And you can see here, when you multiply X by our K value, 1/8. Well, what's 1/8 times 8? It's 1. About 16. 16 times 1/8. We find that 16 times 1/8 is 2. About 24 times 1/8. I'll show it over here. 24 times 1/8. It's going to give you 24 over 8. Divide by 8. Divide by 8. That's going to be 3 over 1. Just 3. You're starting to see the trend here. And notice how much like in the first part of the problem, you start to see this pattern. 1, 2, 3. You can probably continue the pattern. 4, 8, 16. It's counting by 8s. 24, 32. And that's plenty. We can stop there. Explain how you know the relationship of the X and Y values is proportional. You think back to those problems we did where they gave us a table and we would find each K value. That's how you prove it's proportional. For example, this Y over X, again, that's the definition of a K. It's going to be 1 over 8. This one's 2 over 16. But what do you think that probably simplifies to? Divide by 2, divide by 2. 1 over 8. 3 divided by 24. Divide both by 3, you're going to get 1/8. 4 divided by 32. Divide the bottom and top by 4. Again, you get 1/8. So here's how we can answer this problem. As shown by the fact that each Y over X ratio equals 1/8, the table is proportional. Put more simply, we could also just say the constant of proportionality in this table is 1/8. And if a table has a constant proportionality, it is proportional. If it doesn't have a constant proportionality, if one of these was not 1/8, it would not be proportional. But as you saw, the constant proportionality was 1/8, and the table is proportional. Lastly, what equation models the values in the table you created? Well, this is actually quite easy because we already know our k value. We chose it. Our k, we said, was 1/8. And we know the formula, or I should say the format of the equation here is always y equals k times x. Just plug in your k value. Y equals 1/8 times x. That would be in our equation. You'll notice that, hey, if I plug in 8 here, 8 times 1/8, it's 1. That's your y value. But this is our answer. That's our equation.